Hello everyone and welcome back to the VTUC programming series. We have been covering the term marks which are prescribed by the VTU. We have already covered three term marks in the previous three videos. Let us discuss the fourth term mark. So the fourth term mark problem statement is given by we need to write a program to balance the chemical equation. So there are some other conditions for balancing the chemical equation, like there are chemical equation values such as x, y, p, q, which we need to take as the input from the user, and our task is to find the values of three constants b1, b2, b3, such that the equation should be balanced on both left hand and the right hand side, and it must be the reduced form. It must be the reduced form. So before before moving into building the logic, let us look at how the chemical equation looks like, and how we can uh, visualize the constants and chemical equation values. So here they have given x, y, p, q as equation values, which is to be taken from the user. So you can see here, consider this chemical equation, simple chemical equation, B1 AX plus B2 BY, giving product as B3 amount of AP BQ. So here the subscripts X, Y, PQ of subscripts X, Y, PQ respective of A, B and AB compound is the subscripts to be taken as an input from the user. So these subscripts indicate the amount, not exactly amount, the ratio of like X atoms of A element and Y atoms of B element, like that kind of information they give. And there are three constants like B1, which is related to AX, B2 for BY, and B3 related to AB compound. These compound gives us the value of how much amount of A to be added, how much amount of B to be added to form a compound of AB, which will be in the ratio of, not in the ratio, which will be in the amount of B3. So a simple chemical equation, you can say two reactants A and B, and giving us a compound as AB. So I think it is pretty clear with this equation. This is the problem statement. X, Y, P, Q given in these equations are already given by the user X, Y, P, Q. We need to find the B1, B2 and B3 such that the equation is balanced and it should be in the reduced form. Let us look at some input output. Consider this as the input x equal to y, x equal to 2, y equal to 3, p 4 and q 5. For this given input, the required output is b1 equal to 6, b2 equal to 5, b3 equal to 3. How this b1, b2, b3 values are coming? First, write the x, y, p, q values in the equation. Like A2, the 2 stands for x equal to 2. B subscript 3 stands for y equal to 3. A subscript 4 stands for P. B subscript 5 stands for Q. Write this and keep the constant initially blank. That is 6, 5, 3. Initially keep them as a blank and try to balance on both the sides. You might have did this in your PU colleges or in your school days. The balancing, the simple balancing balancing chemical equation. That trick only we need to use. But in programming, we need to be little like very specific. Like whatever act we are doing in the programming, we need to be very specific, because uh, in the program we need to give each and every task in the form of an instruction, so we need to be very specific. So how we are doing it here? We are trying to balance the amount of A on both hand side to be coming out to be same. Like here, 6 into 2, 12 is the amount of A, and here 3 into 4, which is amount of A on the product side. On the reactant side also 12, on the product side also 12. So this is like we have already we balanced the A value, the element A. Similar way, 5 into 3 for B and 3 into 5 for B, which is coming out to be same 15 on both sides. So this is how we balance the equation. We have given another same input output over here, which you can go through. Pretty simple one, same as this. Our aim is to balance on both the side, and it should be reduced form. Reduced form means there should not be any common multiplier between reactants or products like that. So what is the approach to be followed? First approach is we need to read X, Y, PQ value from the user. After that, we need to check if P mod X means if the number P is completely getting divided by X or not. You can see here P is the subscript of X, so subscript of A on product side, and X is subscript of A on reactant side. We need to check this number P is getting completely divided by this X, means P mod X. We are using here modulus operator, which returns us the reminder. If this modulus is coming out to be 0, and we have another condition, that is Q mod Y. Q is the subscript of Y and Y is a subscript of B. On the reactant side, Q is on product side. So Q mod Y is also coming out to be 0 or not. We need to check. If these two conditions are true, then we need to do just this operation, these three operations. That is B1 equal to P by X and B2 equal to Q by Y and B3 as 1. This will give us the B1, B2, B3. This is a simple case. Whenever P mod X is 0 and Q mod Y is 0, when these two conditions are met. But if these two conditions are not met or any of the one condition is not met, then we need to use the GCD approach, greatest common divisor approach, to find out the B1, B2, B3. This is how we calculate that. It is better if I show it using ID. We will code it along. So let us begin. We will begin by including the header files. Let us include stdio and stdlib both. Stdlib is may not be necessary, but we will include it later. We can see whether it is necessary or not. stdio is necessary for doing standard input and output operation. The first step in the programming is to begin the program execution from main function. So in the main function, we will have x, y, p, q. These variables are needed, and we will print a message to user saying enter these variables. Let us read these variables using scanf function. We are reading x, y, p, and q variables respectively using scanf function from standard input stream. Once we do this, instead of doing all the operation in this main function itself, what I will do is I will create a function. A function is nothing but a set of code executed for performing a specific task. Here I will call the function balance, and I have not yet written the function definition. I will write it now. I will call it using four parameters. They are nothing but xy, p, and q. These four parameters are necessary for finding us the value of constants b1, b2, b3. Now we will write the definition for this balance. We will print the value of b1, b2, b3, b4, b1, b2, b3 in the balance function itself. So we will have a wide return type. Wide return type means a function is not returning any value after its execution. The four arguments are xy and xy, p, and q, and all of them are in the form of integer data type. Let us have three constants declared first: b1, b2, b3. As I told, the first approach is to check if p mod x is coming out to be 0, and we have another condition, that is q mod y is also coming out to be 0. This one I am saying. If p mod x is coming out to be 0 and q mod y is also coming out to be 0, then just do these three steps and finish. That is b1 equal to p by x, b2 equal to q by y, and b3 equal to 1. Why I am doing this is because if the p is completely dividing by x, means p is one of the multiplier of x. So, and in the similar way, q is one of the multiplier of y. Whenever there is a common term, what we can do is we can find the constant b1 by using by dividing the value p by x and q by y. This will return us the two constants which are in the form of reduced, and they will also balance the element a and b on both sides. So as B1 and B2 will be containing the respective uh, P by X and Q by Y value, in the B3, means in the reactant side, there will not be any value left because we have already balanced the P by X value in the B1 and Q by Y value in the B2. So in the B3, nothing to be written. So we will be having 1 as a value in for the B3. So we will write the same over here. B1 equal to P by X, B2 equal to P not P Q by Y, and B3 as 1. If it is if the P mod X equal to 0 and Q mod Y is equal to 0, in that case these three statements will perfectly work. What if the above conditions are not met, that is in the else block? Then we need to think how we can do it. See here. Here we have PQ, and on the reactant side we have XY. What we will be doing here, we will be multiplying this P by P into Y. We will be updating the value of P by P into Y and value of Q by Q into X. Like the subscript of A, we are multiplying with subscript of B on the of the reactant side, and subscript of Q of the product side, we are multiplying with subscript of A on the reactant side, so that we can get the we can be able to find the GCD. The next step will be, after multiplying this, the next step will be finding GCD. Once we do this multiplication, that is updating P by P into Y and Q by Q into X, the next step is GCD. Before that, we need to update the value of B3 also, so that B3 will be containing the multiplication of X and Y, because B3 is nothing but the amount of A and B together. So B3 should also contain the multiplication of X and Y. Let me show here. Let us have P equal to P into Y and Q equal to Q into X. Remember, we are doing this only if the P mod X is not equal to 0, or Q mod Y is not equal to 0, means any of these two conditions are failed, then we are doing this else block. Another thing to be done is B3. We will be finding the value of B3 using X into Y. Now we need to find the GCD. GCD of which numbers to be found out? We need to find the GCD of P. No, first we need to find the GCD of Q and B3. We will be first find the GCD of Q and B3. Then we will find the GCD of that result with GCD of that result and P. Or you can do GCD of B3 and P, and later you can find the GCD of that first operation with respect to Q. You can observe here. We will have a temp variable for that. We will have a GCD of P, GCD of Q and B3, because we need to find the GCD, means greatest common divisor among the reactant side. What all things are there on the reactant side? P, Q and B3. So we will be finding the GCD of these using GCD function. Remember, we have to write the GCD function also. We have not yet written. We will write it over here. Int GCD. First, we will complete the GCD function. GCD function will take two parameters, two arguments, int A and int B, two integer values, and it will compute the GCD using. I will show the recursive approach over here. If B is equal to 0, return A, else return GCD of B, comma A mod B. Yes. So this is how we find the GCD of two numbers. We are using here recursive approach. Recursive approach means one function calling a function calling itself is called recursive approach. So the base case means the terminating case here is whenever the B becomes 0, we are returning the A. If B is not 0, till then we are calling the GCD of, means the function calling itself again with the parameters B and A mod B. So the A mod B is done to reduce the value of B until 0. At one point, the B, means the second parameter, becomes 0. At that point, whatever the value of A is there, means whatever the value of first parameter is there, that will be returned as a GCD of the original number. It is A and B. GCD of this original number. So this is about GCD. Once we found the GCD, the next job is simple. That is B1. We will find the B1 by C. The B1 is related to A. So A on the reactant side is subscripted by P, and B2 is by Q. B2 is related to B, and B on the reactant side is related to Q. So P by this GCD result, that is temp, and B2 equal to same Q by GCD result, which is nothing but by temp variable, and B3 also we will do B3 by again temp. B3 is not related to any subscript. It is wholly related to AB compound. So this is this two cases, that is if P mod X equal to 0 and Q mod Y equal to 0 is correct, then execute these three statements and finish. If not, go for the GCD approach and find the value of B1, B2, B3. After that, we need to print the value of GCD because, sorry, print the value of B1, B2, B3 because we are not returning the values. We will say the, like this, we'll say B1 equal to percentage D backslash N, B2 equal to percentage D backslash N, B3 equal to the backslash N I am using so that each of the B1, B2, B3 values will come on the new line. We are displaying B1, B2, B3. So this will do our job. Let us run it and see. It is asking enter the value of x, y, p, q. We will take this example only. X equal to 2, 3, 4, 5. Sorry, x equal to 2, y equal to 3, p equal to 4, q equal to 5. That is 2, 3, 4, 5. B1 is 6, B2 5, B3 3. 6, 5, 3. Yes, we have got the correct answer for the first input. Let us try 1, 2, 3, 1. 6, 1, 2. 6, 1, 2. Yes, the program is giving us the correct outputs. You can try it with different possible equations like formation of H2O, formation of NaOH, NaCl, and try to uh, check with the possible other inputs and see if the program is working correctly. Thank you.